Hey everyone, welcome to our talk on anomalies in relational databases, where data is organized in tables and columns. I am Satyajit. Today we are diving into a key topic for anyone working with databases. During this presentation, we will explore what anomalies are, why they cause chaos in your data, and how to fix them with proper design. If you have ever hit a snag where your database would not let you add data or you accidentally lost something important, this is for you. Let us get started. So, what exactly are database anomalies? Think of your database as a big, organized library. Anomalies are like books getting misplaced, duplicated, or lost when you try to add, update, or remove them. These are problems that mess with your data's integrity, making it inconsistent or hard to manage. They pop up when your database design is not optimized, often because it has not been normalized. Our mission today is to understand these issues and learn how to keep our data clean and reliable. There are three main culprits when it comes to anomalies: insertion, deletion, and update. An insertion anomaly stops you from adding data because the table's design is too restrictive. A deletion anomaly makes you lose data you did not mean to when you remove a record. And an update anomaly causes inconsistencies when you have to change the same data in multiple places. Each one can wreak havoc, but we will walk through examples to make them super clear. Let's start with insertion anomalies. Picture a table called student courses that stores student ID, student name, course ID, course name, and instructor, with the primary key being both student ID and course ID. Now, imagine you want to add a new student, Alice, who hasn't enrolled in any courses yet. You try to insert her, but the table demands a course ID since it's part of the key. Without a course, you are stuck. That's an insertion anomaly. It blocks you from adding perfectly valid data because the table's design is too rigid. Next, let's talk about deletion anomalies. Using that same student courses table, suppose we have three students: Satya and John enrolled in DBA course and Ram enrolled in Java course. If Ram decides to drop Java, you delete his row. But oh, deleting that row also wipes out Ram's name and ID, even though he is still a student at the school. That's a deletion anomaly. You lose important data you meant to keep just because student and course info are tangled up in one table. In our students courses table, let's say Satya and John are enrolled for DBA course. If the college decides to change the name of the course from DBA to database administrator, you will have to update both the rows. If you miss one, the same course ends up with multiple names. One row says DBA, the other row says database administrator. That's an update anomaly. Redundant data forcing you to update multiple places, risking inconsistencies if you are not careful. So, why do these anomalies keep happening? It all boils down to bad database design. When you cram too much into one table, like mixing student details with course info, you create redundancy. Some fields might also depend on part of the primary key, or they are related to each other in weird ways. This leads to data getting duplicated or tangled, setting the stage for insertion, deletion, and update problems. It's like trying to store all the clothes, books, and kitchen stuff in one drawer. Things get messy fast. Here is where normalization comes to the rescue. Normalization is like organizing that messy drawer into separate labeled boxes. It's a process of splitting your tables into smaller logical pieces to eliminate redundancy and prevent anomalies. We follow rules called normal form. First normal form ensures data is atomic, non-repeating groups. Second normal form removes partial dependencies. In case you have a composite primary key, every field depends on the whole key. Second normal form gets rid of transitive dependencies. No non-key attributes depend on another non-key attribute through a transitive dependency. For example, if A is dependent on B and B is dependent on C, where A is the primary key and B and C are non-key attributes, then C has a transitive dependency on A via B. By doing this, each table focuses on one thing, like students or enrollment, making your database way more reliable. Let's see normalization in action. Instead of our messy student courses table, we split it into three tables, keeping in mind that there is a many to many relationship or cardinality between student and courses. A student can enroll into multiple courses, and a course can have multiple students. The three tables are a students table with just student ID and name, a courses table with course ID and course name, and an enrollments table with student ID and course ID to join the students with the courses that they are enrolled with. Now you can add Alice to the students table without needing a course. You can delete John's Java enrollment without touching his student info. And if Satya changes his name to Satyajeet, you only update one row in the students table. It's clean, efficient, and anomaly free. So, what's the payoff for normalizing? Everything. You can insert new students without being forced to add course data. You can delete enrollments without losing unrelated info like student names. And you can update data like a name change in just one place, avoiding inconsistencies. Plus, normalization cuts down on redundant data, saving space and making your database easier to maintain. It's like giving your database a solid foundation to handle everything you throw at it. To wrap things up, anomalies, insertion, deletion, and update are like gremlins in your database, causing chaos with inconsistent or lost data. They stem from poor design, like stuffing too much into one table, but by normalizing your database, following those normal forms, you can banish these gremlins for good. A well designed database is reliable, consistent, and easy to work with. So, next time you are building or fixing a database, make normalization your go to move. Thanks for listening. Any questions or real world examples you want to dive into? Anyways, I will be making a separate videos to discuss database normalizations in detail. If you found this video helpful or learned something valuable, make sure to hit subscribe button and follow the channel for more insightful content. Thank you very much.